So first, thanks for organizing and having me in this event. And my name is Zehao Qin, and I'm going to present the topic of the poster. The title is the three-dimensional visual attention map heat map in space. Shall I just add this one? And measuring and modeling navigational behaviors in built environment. So I would like to start with the question is where we look at when navigating in the built environment and how we measure the area we looked at. So this always been a question or kind of things we wanted to do. So the problem is visual attention represent the subjective perceptual quality, some stimuli possessed within the visual scene that affects pedestrian potential navigational behavior, because sometimes some kind of elements in the space will affect their kind of behavior in some ways. So the overall hypothesis is that humans' navigational behavior correlates with the visibility of the objects in space, maybe the color, maybe the material, maybe some kind of sculptures. So there will be three questions to achieve this, which is the first one is beside the longest line of sight, which is the isovist, is there any effect of the architectural elements such as the colors and materials on visitors' patterns of the movement or explorations? And the second one is what kind of elements in space will affect pedestrians' navigational behaviors, maybe change their minds or change their moving direction or change the purpose of the navigation. And the third one is which part of the space will be highly attractive within the three-dimensional space, for example, like some kind of tiny corridor, something like that. And so for this poster, we want to provide a better understanding of the pedestrian viewing behavior by kind of analyzing recorded pedestrian navigational behavior from images or from videos, from recordings. And we also want to provide a tool that will extend the capability of the spatial analysis because those are basically from two-dimensionality to three-dimensionality. So for developing this methodology, we kind of divided in four parts: data, isovist, and ray tracing, and visual attention map, and finally, we want to do a comparison between different kind of data. So from the data, we kind of record pedestrian path using images. So those images are taken on the site from the video, from camera. And we also want to identify and modeling the space, and we want to record the head movement and location. And for the isovist and the ray tracing, we want to measures of the attention. So we want to develop a way of measuring how to measure the attention. And visual attention map is we want to defining the geometrical shape of the three-dimensional isovist because we used to have the kind of like the torch, like two-dimensionality. So we want to kind of develop a three-dimensional isovist. And finally, we want to do a comparison between different types of data. So the first one is individual's navigational behavior from individual. And second one is different destinations. And third one is we want to compare different values for different types of data. And for the data, we model the space by, this is the space in the UCL main library as the ground level, which is the Zehao Qin building. And you can see on the left-hand side, there's kind of the model. And we categorized 7 elements in space, for example, like the paintings, the UCL map, and statues, and some kind of graphical elements on the wall. And on the right-hand side is the way how we record or how we measured their head orientation by referring some kind of point in space. And I place a camera in the scene and capturing this panorama photos. So basically, we captured 4,000 images within one day from 9 to 5 p.m. And there were roughly like 400 pedestrians wandering the space. So there will be like 4,000 data we recorded in total. And for the visual attention map, because we are kind of developing a three-dimensional visual kind of attention value, like the isovist. So the visibility map is accumulated quality measure of the space that can be seen from the given location. And we kind of following the line of sight and the angle of the view, which is the horizontally like 120 degree, and vertically is 175 degree. And the visibility map encodes 4 different elements: occlusion, viewing angle, distance, and view of the view. And the visual attention value is indicating that the numbers of the intersections between three-dimensional isovist from the viewer and the cell. So for example, like every cell store or calculate how many intersections is happening in one cell. So we kind of remap the value from 0 to 1. So that's how we get a kind of heat map from one kind of data from one location. So this is all the data we recorded on the site, and we kind of remapped all the movement. So this is roughly like 400 movement in the space. So you can see on the right top corner, most of the rotation is happened in the center of the space, because when people are kind of entering the space, they're trying to rotate their head to kind of figure out what's going on inside of the space, even they're having their destination or purpose of the movement. And on the right bottom corner, you can see the capital B and G and F. Those are the 4 elements that is indicating the UCL map and the UCL buildings detail and 2 graphical elements on the wall. And from this one, I separated in 4 different surfaces. So you can see on the left-hand side, so for in total, within one day, most of the people are kind of looking at the UCL map, getting roughly like a 0.75 value in total. So next, we want to kind of dive into detail to individual. So that is how I get the data from one person within the guy was kind of walk from the south part to the north part. I'm getting the data from the set of the photos. You can see the guy was kind of standing at the center of the space by turned his head left and right. And from this right top corner, the image is showing the movement, the patterns of the movements. It's a little bit like changed because of he's kind of looking at the left-hand side and left and right, because the lines of sight is kind of changing a lot at the center of the space. And by seeing the right bottom corner, you can see the capital B is indicating the UCL map is maybe is a kind of elements is attracting his attention at the moment. So you want to dive detail into the kind of the heat map, and you can also see on the right top corner, the tiny heat map is showing along his movement. He's kind of looking at the paintings, because there's a kind of paintings on the wall, but that is not the kind of the visual attention that the elements has grabbed his attention, because he's kind of walking in that direction. That is maybe something we need to like figure out. And the second one is we kind of figure out, find individual is walking kind of backward, because he noticed something on the wall, like the graphical elements on the both side of the gate. So you can see from this image, you can see he's kind of walk past the gate, but turned back and go to the UCL main quad. Because of what? Because of the left bottom corner, there's a graphical elements, or the lines of sight is kind of attracting his attention, and he moved into that direction. And the final one is we find out this one is in the more common way, because most of the people are kind of visitors. They walked in this space and trying to find something to look at and trying to find a map, for example. And he is moving at the center and turn his head to the left and seeing the map and keep walking to the south of the space. So you can see the patterns of the movement is slightly changed because of the elements on the wall. Is the capital B, which is the UCL map, is kind of attracting his attention, but he will like keep move to the same direction. You can see here, you can figure out, okay, that is maybe the graphical elements or UCL map is becoming the most attractive elements at the moment. So as the result of the visual attention heat map was able to achieve a convincible result of the visual attention in three-dimensionality within the interior space, and even in the open space. But in the open space, we have the more limited parameters. For example, like the viewing angle might be limited into specific 90 degree or something, because the distance of the viewing objects is quite different to the interior space. And connection between present spatial analysis. So I think that is a kind of strong connection between existing spatial analysis. And visual attention could be measured, modeled, and visualized in three-dimensional. And the current methodologies of measuring visual properties, such as visibility graphs or visibility connectivity, could be improved by incorporating visual attention analysis. Maybe you can figure out if the data or the result is correct by incorporating the visual attention map, heat map. And some parts of the space will be more visible than other parts, such as the sculpture on the north wall, or maybe the UCL map is becoming the most attractive elements, which will obviously affect pedestrian navigational behaviors. And the result of the visual attention heat map showed that people mostly follow the lines of sight, but some kind of objects, for example, like colors in the space, will affect their navigational behavior, showing their behavior was goal-oriented, but affected from unexpected stimuli. So those are the reference and this poster. And thank you. That's all my presentation.